In front of you is a ballistic missile consisting of 5 parts, and each of these parts has its own specific function. But before we explain these parts, we first need to know why it is called ballistic and what ballistic actually means. The word ballistic refers to projectiles, and projectiles are things that fly and depend primarily on the initial throw for their flight, like throwing a ball or a stone. Ballistic missiles follow the same behavior as this ball in front of you. The distance it covers depends directly on the strength of the throw, and there must be an angle for the throw, meaning you don't throw it vertically because it would return to the same place. Returning to the 5 parts, we will start from the left, the largest engine, which gives the first push that provides the missile with a very high initial speed, so that this takeoff process is very powerful. And it must be powerful because the most important feature of anything considered ballistic is that the first push is strong, as this push is what allows it to reach a further distance. True, there are 2 additional engines, but they are not as powerful as the first engine. For this exact reason, it is called ballistic, because it relies on the toss rather than sustained flight. As for how it works, this engine operates according to Newton's third law. For every action, there is an equal and opposite reaction in magnitude and opposite in direction. This engine has gas ejected at very high speeds backward, and according to Newton's law, the missile will be propelled at the same speed and force, but in the opposite direction, meaning forward. The second engine, or you can call it the booster, its function is to give a very large push during launch. It doesn't wait until after it has flown and crossed the atmosphere. It starts immediately after the initial toss. Why immediately, if the first push was so strong? The reason is that during the missile's journey, the hardest stage is takeoff, because at this moment the mass is at its highest due to the missile being full of fuel. Keep this information in mind. Fuel represents more than 80% of the missile's mass, and at this moment, your fuel is full in the missile, so its mass at this moment will be the largest. Not to mention that it will also be affected by air resistance, since the air below the atmosphere is very dense. The third stage, which represents the third and final engine, this engine gives a third and final push to the missile after the missile is already in the air. You don't need a massive engine at this stage, because the resistance has become less than it was down below. So, in short, this stage is a very simple engine that will give a final push to the missile as a final boost, and its mission ends. As for the fourth part, this is literally considered the brain of the missile, because its job is to guide the missile to its destination. It converts the random thrust that occurred into a calculated path heading toward the target. What is this is a microprocessor located in this spot that compares the current path with the planned path, corrects the trajectory, and makes it go to the correct location. Developing this part along with the first engine will make the missile much better. Why? Because the first engine is the foundation for ballistic missiles, and this part is what directs it on the correct path. So if you develop both, your accuracy in hitting the target will be high. The mission of all the previous parts was to deliver this last part to the target. Why? Because, quite simply, this part is the one that contains the explosive materials. As for its shape, why is it conical? The reason is to reduce the shock when the missile re-enters the atmosphere. As I mentioned, the missile will leave the atmosphere and then re-enter it, as you can see. Leaving it usually isn't a problem. The problem will be in the entry. Why? Because it will have moved from low density to high density, and as a result of this, there will be a shock. The conical shape is considered an excellent shape for absorbing shocks. So as you can see, these are the 5 stages I explained, from A to E. You have the first engine at the beginning, then the second engine, the third engine, the processor, and finally the payload, which contains the restricted materials. Now, here is our missile, down here. It will fly and reach a certain place. The important thing I didn't explain earlier is that after each engine finishes its fuel, it will separate from the body of the missile. The first engine, after finishing its fuel, will be dead weight with no benefit, just extra weight on the missile, so it gets rid of it. The same goes for the second engine, and of course, even the third engine will separate. The reason is that all these parts had only one function, to deliver this final part to the target.